Right, this is question 3 for June 2014 Edexcel A2 and for the C3 paper. This question is a little bit more challenging. The first part, part A, isn't very bad at all. Okay, so what we're told, for those of you that don't have the question next to you, that x is equal to 8y times the tan of 2y. Okay, so what does the first question say? Well, it says the point P has the coordinates. I'm just going to break it down. It gives you in the coordinate form. I'm just going to say that x is equal to pi and y is equal to pi on 8. Now that tells you instinctively that it's in radians, because you see pi and we've got some trigonometric function in there of tan. Okay, so the first thing says verify that P lies on C. This equation is the equation for C, the curve. So all we have to do, this is only worth 1 mark, you should know there's not that much to do, because generally they don't give marks away for nothing, or in this case, it looks like you do. So anyway, you just put your values in. So you've got a value for x, so you say pi equals 8y, so that's 8 times pi over 8, which is obviously just going to be pi. So therefore, times tan of 2y, that's 2 pi on 8 or pi on 4. And tan of pi on 4 you should find if you have your calculator in radian mode. So I'm just going to put mine, yep, it's in radian mode. So if we do the tan of pi on 4, you should get the answer equal to 1. And that's so therefore, pi times, what this is pi equals pi times 1, which is correct. So therefore, P does lie on C, etc. So that was just part A. That was very quick. All we had to do is plug in our coordinates that we got given of your x and your y into the original equation and said that works. So therefore it must lie on the equation of the curve, otherwise it wouldn't work. Now you don't need to say all that, obviously that'd be a waste of time. I'm just explaining to you how this equation works. So sorry about the lighting, it's really annoying me as well. Damn camera. Right, what? I just have to deal with this, sorry. Sorry about this, 1 sec. I'm sorry if I've made your computer screens go funny, but normally that solves it because the focus is autofocus, so we changed the lighting in the room. Should alter it. Sorry if you can't see that. This might just be coming out of my camcorder screen funny, but if it's not, I do apologise. So anyway, we said basically you plug in your numbers into the original equation of the curve and it should come out to be equal. And if it isn't, then obviously you've done something wrong, because it wouldn't create an equation that doesn't work. The next bit is a bit more challenging. It says find the equation of the tangent to C at P in the form A, Y equals X plus B, where the constants A or B are to be found in terms of pi. You can ignore the rest of it, you just say find the equation of the tangent to C at P. This is C, pi on 8. Now, the first thing I always do when we've got our x value, so as a tangent is in the form y take y1 equals m, x take x1. We need the gradient, as we've got the x is equal to pi, and we're told y is equal to pi on 8. So therefore, we need to know what m is. Now we find m by doing the derivative, the gradient function, dy by dx. So we are told, yeah, okay, so this subject to the equation, so we said x is equal to 8y times the tan of 2y. So if we were to go into a hideous mess, it would be very, very hard to get this equation in terms of y. Almost impossible, in fact, purely just in terms of, so y equals x. It'd be quite hard to do that. So what we do instead is, we know what we want to find dy by dx. But we know that dy by dx is equal to 1 over dx by dy. Now the reason we do dx by dy is because dx by dy, if we related it to our related rates of change, if you're doing C4, or chain rule in C3, the chain rule in C3 says, if you break it up, it says dy by dx equals dy over d something, we'll call it dt, times dt over dx. And then what them two other bits are saying, so the dt by dx is saying, differentiate the t equation with respect to x. So differentiate the x's in the t equation. So therefore, this dx by dy says, differentiate the x equation with respect to any y's in there. That's the only thing we can do, because we can't differentiate the y equation, y equals x, with respect to x, because as we just said, to rearrange that equation into y is going to be near on impossible. So, what we have to do is we have to work out dx by dy and do 1 over that answer. But this is going to be a little bit more complicated than that, because we haven't simply got one function of y, we've got two functions. We've got this 8y and tan of 2y. Now what we could do, as some of you might have wanted to do, is 8y times sine 2y over cos of 2y. Now that would be good, but what it would mean is you would end up working out something that you should already know. You'd end up working out that tan 2y, if you differentiate it, you could do sine 2y over cos 2y and use a quotient rule to differentiate that, and you'd end up with sec squared over 2y, which is very well and good, but you'd waste most of your life doing that. So I'm just going to leave that on the board as tan of 2y. I'm just going to leave it as tan of 2y. So, the thing we need to recognise here, as I said, there's two functions of y. Now the only formula that you use when there's two functions of something is product rule. Now let me refresh your memory on what the product rule states. The product rule says, so we've got u and v here. So it says the differential of u and v is u times v dashed plus vu dashed, or uv dashed, vu dashed plus uv dashed. It doesn't matter as they're a plus, but it does matter in the quotient rule. So anyway, what we can say here, if we're using this rule, we can say u is equal to 8y, or tan is equal to 2y. You need to keep it constant though. So therefore u dashed is equal to 8. And obviously you could put dy by dx there, but I'm just going to leave it as that. So what the exam scheme says. Yeah, the exam scheme just leaves it as that. Because with, if you were being specific, and using implicit differentiation, which you should do, but in C3, so you're not assumed to know about that yet. Even though you do, anyway, it doesn't matter. So then in tan of 2y, so that's v equals tan of 2y. And then v dashed, as we said, you could do sine 2y over cos 2y, use the quotient rule, you just get sec squared y. Sec squared 2y, sorry. Or you could do 1 over cos squared 2y, but you just end up, I prefer to leave it as that, because it's nice and simple. And you can put it back into 1 over cos squared y in the end if you fancy. So anyway, we use this formula. So therefore, dx dy is equal. So when I've done this, I'll rub these out. So if you want to get them down, you should. So therefore, if we use this rule, so u times v dashed, so diagonals, remember. So 8y times sec squared y. Sorry, that's 2 sec squared y. 2 sec squared 2y, because you bring the front, sorry, forgot about that. So therefore it's 8y times 2 sec squared y, 2y, sorry, making a mess of this, plus v, which is tan 2y, times u dashed, which is just 8. So therefore, if we simplify this down, so expand the bracket, 8y times 2 sec squared 2y is 16y sec squared 2y plus 8 tan 2y. And that's your gradient function of dy by dx. So I'm just going to rub out this v and u dash because we need a bit more room on the board for the end of the question. So that's a gradient function, which is all very well and good. But we have to put in our numbers now. So therefore, 16 times y, we said y was pi on 8. So 16 times pi over 8 is 2 pi. But I'm going to leave it as 16 times pi on 8 times sec squared of 2y. Sec squared of 2y is sec squared times pi on 4, or 2 pi on 8, whichever you want to say, plus, so I'd square bracket that if I was you, was what I do, because then it's nice to see the clarity between your answers. 8 times tan 2y, so that's 8 times the tan of pi on 4, or 2 pi on 8 as we said before, whichever you prefer. So therefore, if we expand this out and simplify it down, I'm not going to do that step because 16 times pi on 8, that's 2 pi. 2 pi times sec squared pi on 4. That's 2 pi times sec squared pi on 4 plus 8 tan of pi on 4. So that's 2 pi sec squared pi on 4. So that's 2 pi times 1 over cos squared pi on 4. So that's, yeah, so you could do 2 pi over cos pi on 4 times cos pi on 4 to get cos squared pi on 4, plus 8 tan pi on 4, so that's how you'd put it in your calculator. And if you did that, so I'm not going to do that in front of you because I'm going to waste time, you should get 8 plus pi. It's pi, 4 pi, sorry. So 8 plus 4 pi, and that's your gradient function, that's not your answer, because it wants the equation of the tangent, and now we should say the tangents are the same gradient as the curve at that point. That's why I generally write down as a little star at the beginning of the question, but you know, it wastes time, but I like to remind myself of what I'm doing in the question, because otherwise I'll get halfway through the question and be so involved in the math and forget to do something with the gradient if I needed to, which luckily in this case I wouldn't do, but just to keep the method going. So anyway, that's the gradient, 8 plus pi on 4. So therefore, y take y1, so y take pi on 8, equals the gradient, which is 8 plus 4 pi, times x take x1, x being pi. Now, it wants it in the form ay plus equals ay plus x equals x plus b or whatever. So therefore, we need to get rid of this pi on 8 because there's no fractions in that equation. So therefore, we times all of it by 8. So that's 8y equals pi, sorry, take pi, equals 8 times 8 is 64, plus 4 pi. 4 pi times 8, so that's 4 times 8, which is 32, so plus 32 pi, times x take pi. Now, I've not got quite enough room there to simplify that down. Oh, wait, just done something majorly wrong there. So, good job if you spotted this actually. So before I go any further, I made a little mistake there. So actually that's a good thing to point out. Don't forget, as I did, to do this 1 over dx dy, because what we've worked out there is dx dy. So therefore, the gradient is actually 1 over 8 plus 4 pi. So it's not 8 plus 4 pi, so it's 1 over 8 plus 4 pi. Which if you times by 8, you'd get 8 over 8 plus 4 pi. Which I think, put in your calculator before I make another mess of this. So that's 8 over 8 plus 4 pi. Which your calculator doesn't, if you put that in your calculator you get a decimal thing. Which is just meaningless. God's sake, it's really testing my maths. Yeah, so it's 8 over 8 plus 4 pi. You could simplify that down. I'd just make a mess if I tried. God's sake, I can't believe I've made a mess of that question, so I do apologise about this question. I did practice this. That's a good idea actually. Sorry, I'll just be a second, I'll see what I did, because I am slightly making a mess of this. So this is question 3A. So it's 3B, sorry. Yeah, I did make a mess of this in my answer as well. So anyway, I'll just give you the answer. Oh, so actually no, you don't need to convert that. Yeah, so you can, sorry, what I was just working out in the answer. So therefore, 8, sorry, really should have attempted this before, and I did, but I just made a mess of it in my attempt. So I probably should pay a bit more attention before I attempted to explain it. Obviously not very well. Anyway, the end answer is on the mark scheme online, which is 8 plus 4 pi times y. So 8 plus 4 pi times y, and I'll have a stab at explaining this. Now how they got to that, if I can manage it. So that's equals x plus pi squared onto x plus pi squared onto, okay, almost cuts off there. Right, white shirt. So anyway, baffled there, my problems. So anyway, that's what they did there. Right, so what they did was times both sides by 8 plus pi on 4, and then simplified it down to get that 8 plus pi, 4 pi times y equals x plus pi squared on 2. Now, you would get most of the marks if you left it at that and didn't know what to do from there. I'm sure that's what I would have done. But if you'd have got the answer, great. As I said, if you can think of a way that makes it seem a bit less complicated than I've done, please do comment, because I think I made a little bit of a mess of answering that one. But yeah, it works sense in my mind, but if it doesn't in your mind, just let me know and I'll try and have another stab at that. But I think that's an okay explanation. And I pointed out a few things. As I said, I made the mistake of not doing 1 over that, which I should have done, because that's not that's not dy by dx, that's dx by dy. So you need to do 1 over that to get your gradient function, and then you just simply put in your equation for a straight line. But you need to put it in the form that they wanted, not the form that I attempted to do. So anyway, thanks for watching. That's question 3. We're going to go on to question 4 next. So we'll see you. Question 4.